Hey guys, we're going to be going over the natural exponential function, the derivative of that one. And there's just some key points that I want to just mention. The derivative of e to the x is always going to be e to the x, okay? And that's going to be real basic. So derivative of e to the x is always e to the x. That's only if the exponent is just x. If it turns out to be like a 2x or x squared, if there's anything else attached to that x, then it's going to be this formula. So the derivative of this should be here, the derivative of e to the u is du eu, okay? Du eu is the formula. Now here's some key points that you guys can look over. This is the graph of e to the x, okay? And also it's important to know that the inverse of e to the x is natural log of x. We also know that it's continuous and it's increasing, which is called monotonic, and it's always above the x-axis, okay? It is also important to know that whenever you take the limit of e to the x as x approaches negative infinity, which means you're going this way forever, that your y value, that it's approaching the y value of 0. That's why it's equal to 0. On the other hand, if you're going to positive infinity, it shoots straight up, so your y value approaches positive infinity. Exponential functions grow faster than polynomial or logarithmic functions. That's going to be important later on, okay, whenever we start reviewing for limits, okay? All right, so let's go ahead and get started. So if you notice here, this one we're going to end up using this formula that we have here, so du eu. So this means we're going to take the derivative of the exponent times the original. So y prime is going to be, what's the derivative of 2x minus 1 is 2 times e to the 2x minus 1. And that's it, you're done. There's no other trick to it other than that. Okay, this one here, it's going to require you to use the quotient rule. So it's giving you the function, you have to find the derivative. So f prime of x, using the quotient rule, it's ho, so it's going to be 2x times the derivative of the top, which is times 2e to the 2x. So the derivative of this portion is 2, and then times the original is e to the 2x, minus, so it's going to be ho d high minus high, so e to the 2x, times the derivative of the bottom is 2, over 2x squared, okay? And you can rewrite this just a little bit. So 2 times 2 is 4, and then rewrite the x, e to the 2x, minus 2e to the 2x, over, square this, it's going to be 4x squared. So this is your final answer right here. You can simplify it by maybe factoring out a 2 and then reducing it with the 4, and maybe even factoring out an e to the 2x, but that's not necessary right here. Okay, now here it's going to be, if you guys remember the derivative in disguise, this is the definition of the derivative using limits, okay? So it says if you have a function e to the x, which of the following is the equal to f prime of e? So what you need to remember is the definition, the formulas itself, okay? So if you remember, let me go ahead and write it down here on the bottom. We have the limit as h approaches 0 of f of x plus h minus f of x over h, okay? This is for f prime of x, okay? So if this is going to be an e, if it's going to be an e there, then I'm going to replace this with an e and this with an e, right? So this first term should have e to e plus h, okay? So notice here, it doesn't have an e, does it? So that one's not the right answer. This one, close, right? We have the e here, but let's analyze this second portion. I'm sorry, let me turn on the light. So this portion here has e plus h, which is kind of like what we need here, right? And this portion, the difference between these two is that this one has e to the e. So if I'm plugging in e into something that already has e to the x, I should also have e to the e. So it should be this portion here, okay? Because this one's saying f of e. F of e, here's f. Wherever there's an x, I need to put in another e, so that's why it's going to be c, okay? Here's the next one, and it's going to require us to use the calculator. So I'm not going to go ahead and answer the whole question completely. So basically what we need to do here, it says let f be a function given by f of x is equal to 3e to the 2x, and let g be another function where it's going to be 6x to the third. At what values of x do the graphs of f and g have parallel tangents? So what we need to do here is, if you want to know when they have parallel tangents, this is a key point right here. So parallel tangents, we know that these parallel tangents, they're parallel whenever the slopes are the same. So we can get the slopes of f and g whenever we take the derivative. And if we want them to be the same, then that means we're going to set the derivative of f equal to the derivative of g and solve for x. So here what we would do is we would take the derivative of f, which is this, the derivative of 2x is 2, so 2 times 3 is 6, e to the 2x. And then the derivative of g is going to be 18x squared. So what it's asking us to do is derive this, or actually set these equal to each other. So 6e to the 2x equals to 18x squared. So we just basically need to solve this. We can plug this into the calculator, and what you guys can do is actually practice. I'll go ahead and show you. You guys can go to your TI-89 and go to solve. Okay, it's going to give you solve open parenthesis, and you can type in 6e. When you type in e, it gives you a caret open parenthesis. You can put 2x, and then there's an equal sign there. You can put 18x caret 2. And you have to put comma x, because that's going to be with what it's respect to. Close it up, and you should be getting your answer. And actually I can pull it up here so you guys can compare your notes with what you should be getting. Let me see, where is it? So you should be getting x is equal to negative 3.91. Remember, you need to round off to the third digit whenever you're taking the AP Cal exam. Thanks.